So this topic is basically on the feasibility analysis with focus on cost benefit analysis. So what is actually feasibility analysis? Feasibility analysis is a measure of how beneficial an information system will be to an organization. So you are creating an information system, so you need to make sure that how beneficial that system would be to the organization itself. So feasibility analysis is nothing but that measuring that feasibility. The process of measuring the feasibility itself is called as a feasibility analysis. Now when we check over to a feasibility analysis, there are three major checkpoints. So one is actually the scope definition and problem analysis and the decision analysis. So problem analysis we all have seen in detail. So we have seen fishbone diagram or Ishikawa diagram, which you all know. So where we actually identify the cause and the effect analysis towards a particular problem. And decision analysis, we have seen all the operational feasibility, technical feasibility, all the different type of feasibilities in some of the previous sessions. And scope definition is nothing but if you have a particular problem, how long it will be sustainable, how long it is scalable, how much it's scalable in the future. So these all things are the major checkpoints when we need to do a feasibility analysis. So there are different types of feasibility analysis. One is the operational feasibility, cultural feasibility, technical feasibility, schedule, economic, legal feasibility, etc. So how do we actually consider all these feasibilities when we are actually doing an analysis? So this is something called say we have our own system, and apart from our own system we are actually considering two other contemporary systems, and we need to make sure that what is the percentage of how much is it actually contributed by each of the candidates. So this percentages that will actually differ based on the application itself. So this is not a fixed one, but this will differ based on the application, and sometimes there might be some product which is actually more culturally important, so we need to have a bit more higher percentage on the cultural feasibility. Maybe there is some other technical platform which requires more technical feasibility study to be required, so that time we need to make sure that the technical feasibility study is a bit more intense. So this weightages depends upon the application itself, and however this is kind of a random percentage which is actually given to you. So now this is one small example which you could see. So you are given with this is your candidate, and these are the two other candidates. For each of the feasibilities you are actually getting a score. So when you look at this final score, you are getting the final score of 67, 92.5, 87.5. So just imagine that if yours is the candidate 1, then you need to really think about where it actually it's actually hits you. So technical feasibility, so you need to hire and train people with more expertise. Hence, we need to have a little bit more analysis on the economic feasibility. So when it comes to economic feasibility, there are three things. One is the payback analysis, return on investment, and net present value. So what is payback analysis? Say I have a product, I am giving that product to the market, and I'm investing say 10,000 BD or 10,000 rupees on that. When will I start getting the profit? That is nothing but the payback analysis. So return on investment. So when will I get the return for the investment that I have? What is the net present value? What would be the future value of the product, right? So all those things are really important. So payback analysis is a technique for determining if and when the investment will pay for itself. That when will you start making the profit? So payback period itself is the period of the time that will lapse before accumulated benefits. Say just imagine that you have a product, and the product is in the market, and you are having the maintenance cost, and the product is in the market for the past 3 years. The 4th year you started getting the return on investment, your product started making more profit. So 4th year, so 3 years have lapsed for you to get the profit. So net present value is nothing but the analysis technique that compares the annual discounted cost and the benefits. So you have cost and you have benefits as well. So consider both of them in order to calculate the net present value. We will see it in detail. So in order to move on to the net present value, which uses one of the interest calculations, we need to know what is simple interest. Simple interest, as you all know, that we have principal, we have interest, we have I is the interest rate, and FV is the future value, and T is the time. So if that is the case, then how will you calculate the simple interest? It's very important. It's very easy. P into I into T, and future value is nothing but P into I1 plus IT. Compound interest means you are actually the interest due more than once during the period of investment. That means that, say, just imagine that it works with a compounding effect, right? So this is your future value, and this is how you will calculate your present value. So while identification of the cost, cost means you are spending something. So when you're spending something, so it could be research and development cost, hardware, software, labor, operation and maintenance, because it is something which you have to spend money. Overhead cost and facility cost, these are all the cost. Now there are something called benefits as well. And benefits, if you could see that, some benefits are visible in front of your eyes, some of the benefits are not visible. That means that some is tangible and the other one is intangible. That means that, say, tangible benefits like salaries, the savings on the salaries, and say one staff left but the other staff took up the work, and now you are saving the salary of another person. Reduction in the bad debts and improvement of processes, etc., comes as the tangible benefits. And in the case of intangible benefits, which is not directly calculatable, so that means that the customer goodwill, you're not very sure how will you calculate it or how will you measure it. Improved employee morale, etc. Cost benefit analysis, so this is the way that you have to calculate all the cost, and you have to calculate all the benefits, then the difference between the cost and the benefit, and then you have to apply the tax, then perform the time adjustment for the money in every year, and sum of all the adjusted values. Let's see this in detail. So this is the net present value calculation. So we are actually calculating the FV0, which is the present value, which is the future value at the year 0. That means the developmental year. And when you look at this particular term, okay, when you look at the this second term, this is the second term, this is the second component, and this is basically you are calculating for the first year itself. Okay, you're calculating it for the first year. So when you're calculating it for the first year, so you have FV1 divided by 1 plus I the whole raised to 1. So where did you get that? So FV1 into, so here if you have something like F and you have V, you have 1 into, so if you have something like FV1 into 1 divided by 1 plus I the whole raised to n, that is nothing but this component. Now here the n is equal to 1. That's all. Here your n is equal to 1. Now in the second one, it is nothing but FV2 into 1 divided by 1 plus I the whole raised to 2. It goes like that. So here this 1 divided by 1 plus I the whole raised to n, is that factor is basically called as a discount factor. This is nothing but the discount factor. Now what is actually payback analysis technique? So you need to calculate the time adjusted value and the accumulated time adjusted value, and spot the change from negative to positive. Wherever you identify this particular change, then that point of time onwards, your cash flow changes. That means you will start making profit. So before coming over to this, I will take you to an example. So this is an example for you. So in this particular example, if you could see, here you are actually building a particular product, and the expected lifetime of the system is actually 5 years. And the discount rate is basically given as 12%. The tax is actually given as 17%. and the expected benefits in the system's life is basically given as 70,000. If the total developmental cost and the annual operating cost are like in the below. So you have to calculate both NPV and payback period. So these are all the developmental cost, these are all the expenses, etc. So these are all the spending, and this is also operation and maintenance cost, which is again spending itself. So now when you have this data at your hand, what you have to do is that you need to develop that. So what would you do is that you will take the years as year 1, year 0, 9, it just goes like that, and these are all your developmental cost. Okay, and these are all your personal, like operating costs. So whenever you look at the developmental cost, all the developmental costs will be only in the 0 year. That means you are in the process of developing, and all of them will be negative. Why? Because you are spending the money. And what about the maintenance and operating cost? Maintenance and operating cost will be from the year 1, year 2, year 3, etc. Right? So it is from the year 1, year 2, year 3, etc. Now why is it negative? Because again you are spending the money. Right? So this is the first step. Okay, finding the total cost. So how do I know that? That's the first step. So this is here. See, calculate all the costs, calculate all the benefits. These are the two different steps initially. So that is what we are doing here. So this is actually the calculating all the total cost. So how will you calculate that? You will add all this. So for each of your cell, you have got this formulas here. So please check over to it. Okay. So when you look at here, this is the formula B6. So what is the B6? It starts from here and it goes till 90. So they have just taken it, no values are there, so nothing is going to happen. So this is nothing but the total cost for the year 0, and now total cost for the year 1 is the summation of all these values. So how will I know the formula? Because I'm having this formula here from C23 to 29. So it's the same for everything. Now comes the total benefits. So total benefits, they have not given any splits, so I'm just taking it as 70,000 itself all the years. So now that is done. Now what are we doing is that calculate the difference between the cost and the benefits. So what we need to do is that we are taking this net before tax. So how do we do that? So for that, what you have to do is that you need to first calculate the net before tax. So how will you do that? Net before tax, this is exactly like this, because there is no benefits here, so it is actually 0. So this one plus 0, and here when you look at it, this plus this. Okay, so this is 56, this plus this, like that you will calculate. So each of the cost and the benefit, cost plus benefit is nothing but this before tax. So this before tax is nothing but your total cost plus total benefits. This is nothing but this one. That's the formula says. Now you need to apply the tax. So when you have to apply the tax, it is as simple as that. Here the developmental cost, here you don't have to pay any tax. So that's why you have exactly the similar value here. But when you look at here, you are actually taking it as 0.83. So how did you get this 0.83? 100 minus 17 is 83. So that's why you're getting this particular value. So that into 34. 34 is this one. This is your 34 row. Okay. So your total cost and benefit into tax. Okay. So this whole thing into tax is nothing but these values which you get. Now you need to identify the discount factor. How did you get the discount factor? You know the discount factor. Discount factor is nothing but 1 divided by 1 plus I the whole raised to n. Right? So you are calculating the discount factor. So when you look at here, what would be the discount factor? Is equal to 1 divided by 1 plus I is actually 0, the whole raised to 0, right? So this is what it is, which is 1. So here it is 1, that's all. So your initial thing, so when you look at the formula here, it is FV0, okay, FV0 into 1, right? So when you look at here, this is nothing but your FV0. I mean, like, these are all your FVs, okay? This is your discount rates. And what is this net present value? In net present value, what you have to do is that we have to take all the FVs, okay, all the FVs into discount. That is what we have to do, into discount rate. So here it is 1, and here what is the formula here? The formula is given here, 1 divided by 1.12 the whole raised to 1. So how did you get that? Discount rate is 12%, right? So 12 by 100, the whole raised to 1, whole raised to 2, this is whole raised to 3. Okay, so each year it differs, right? Each year it differs, and it just keep moving on. So this is nothing but your discount rate. Now your NP values. So NP values, each component you need to find out. So this is your first component, FV0. So when you look at this one, this is nothing but your FV0. Okay, this is your FV0. Now what is this value? This value is nothing but your first component itself. Okay, so this is your first component. Let me just take this out. So this component which you see here, right, this component is nothing but this one. Okay, so take out that plus. Okay, this is so we are actually calculating component wise. Okay, each and every component is calculated. So the second one is basically raised to 2. This is basically raised to 3. Okay, so each of the component you are actually calculating here, and this is nothing but raised to 4. So it just goes like that. Okay, it just goes like that. So these are the components. So why do you actually calculate each of the components? Because in your formula, if you want to calculate the NPV, the accumulated, so this is basically accumulated NPV. Accumulated NPV. Accumulated NPV is nothing but addition of all this particular FV value. So if you add this plus this is the NPV for the second year. I mean like the first year. Then if you want to have this particular value, this plus this plus this, it just goes like that. So here FV0 is nothing but this value into this value, right? So here this is actually this into, okay, this into this, right? So that is nothing but your FV0. Now how will you calculate FV1 in divided by 1 into 1 by 1 plus I the whole raised to 1? That you will calculate by adding these two values. Now these two values, like that you will calculate and find out all the individual values. So this into this will give you this value. So when you look at this one, this is 36 is this one into your discount rates. Okay, so we'll give you this value. So that is how each of these values are actually done. Now so you know the components, each of the components, right? Now what you need to do, you need to find out the accumulated. Accumulated is for the first year, it is exactly the same. For the second year, what is happening? This value plus this value. Now third year, it is either this value plus this value, or you can also say that this plus this plus this. Now this value is nothing but this value plus this value, or you could also say that this plus this plus this plus this. So either ways. So finally you will get this whole NPV. So this is nothing but your NPV. Okay, this value is nothing but the NPV. So in your question they are asking you what is the net present value of the project. Net present value of the project is this one. Now can you stop there? No, because we need to calculate the payback period. So how will you start calculating the payback period? You will look for the sign change. So here there is a negative value, here there is a positive value. So here you understood that from the year from the year 4 to year 5 there is a small change. So now how will you actually find it out? Okay, so for that what you will do is that this particular value, okay, this value is 24454, okay, minus and minus of this. So that's why they have actually put an absolute symbol here. Okay, so if I want to do 10 minus 5, it is equivalent to 10 plus 5. So instead of saying like 10 minus 5, I could say that 10 plus mod 5. So that is exactly what is actually used here in this particular statement. So you are actually doing subtraction between these two values. So you will get this value. Now what is this value? This value is actually the change per year. Now I don't want change per year. I want to know that how many months also it has taken. So what will I do? I will take this particular value divided by 12. So just consider the scenario that I have given 100 BD to a particular person as a rent. Okay, I have actually taken 100 BD from a particular person. Okay, now how will I know that every month I need to give, what is the amount I need to give? What will I do? I will actually simply give 100 divided by 12. That is what I will do, right? So whatever be the amount, that is the amount that I need to actually give every month to that particular person to finish off the debt, right? So this is exactly some kind of calculation like that. Now here when you look at it, now I need to know that now I need to know how many months I need to pay. So this is the total amount, right? This is the amount. Now in this amount, I can actually every month I am giving this. So say just imagine that 20. Okay, 20 is the BD that I can pay. So 100 is the amount that I need to finish paying. So how many months it will take? 100 divided by 20. So 5 months I will take in order to pay off that 100, right? So something like that. So this is the amount, right? This is the amount that I need to, I'm starting with, divided by each month I can pay this much of amount. So how many months it will take? So I will take almost 0.89. So that means that 4 years, 0.89 months, that means almost 1 year it will take to make profit. So that is a change from year 4 to year 5, the sign change. So that many month it will take. Now how did you actually get this diagram? So that's why actually we have actually put the 0 1 2 3 4 5 here, and we are taking the accumulated NPVs per year. So go to the insert, go to the graph, and you can have the graph here, right? So this is how you will actually draw the graph. Okay, that's why we have actually put the 0 1 2 3 4 5 here. Now when you look at the graph here, so let's understand this graph. So what do you understand by this graph? So in this graph you understood that this is actually having, so after the 4th year, by almost 1 year you will start making profit. Okay, so this point is basically called as a break-even point. So what is a break-even point? So you have the line which you have the graph which actually shows about the data, right? But when this line hits the 0, whenever the line hits the 0, you will call them as the break-even point. So this is the point where you will actually start making the profit. So 4 years and 0.89 months you will take to make the profit. So this is the payback period. So this is how you will calculate the payback period, or this is called as a payback period analysis. Okay, so this is what it is. We are actually doing it in the cost benefit analysis. So you will be given with different examples and different contents. So what you have to do is that go through it really carefully and understand what is it actually given to you properly, and just make sure that you are completing it on time. So thank you so much. So hope you understood the cost benefit analysis. It's a very important topic, but if you understand it, you can do it easily. Thank you so much. If you have any questions, you can always get back to me. Thank you so much for your time.